Engineering Challenges of the International Space Station, project by Group 9. The ISS is a satellite orbiting approximately 400 kilometers above the Earth's surface. It is operated by 5 space agencies: the American Space Agency and NASA, European Space Agency, Canada, the Japanese Space Agency, and the Russian Space Agency. It represents 15 nations and is one of the most ambitious engineering challenges that humanity has undertaken in the past 100 years. During the construction and operation of the ISS, mechanical and aerospace engineers were responsible for many of the essential components that form the ISS. Engineers are responsible for most of the moving parts and robotic systems that make it possible for the ISS to operate and function. These 2 engineering disciplines, as well as many others, make it possible for the scientists and astronauts who work on the ISS to conduct research safely and effectively. Engineers of all sorts from across the world work to make components that would be assembled in space. To do this, they required government agencies to intermediate plans between these engineers, negotiate ISS requirements, funding, and launch times, all while communicating with the heads of other nations' space agencies. One specific task assigned to Canada through these government agencies was the Canadarm2. This robotic arm, designed by Canadian engineers, was used to assemble components of the station in space. It was required to be designed to work with pieces of other nations and funded by the Canadian government, requiring engineers to work heavily with their government and administration. While the ISS used many rare earth metals and finite resources, when considering the number of rocket launches used to travel to the ISS and keep it running, this becomes its only significant environmental impact. There have been over 400 flights to the ISS, with each flight releasing between 400 and 500 tons of greenhouse gases depending on the rocket. While this is a huge amount of CO2, the rarity of the flights makes it a fraction of some nations' emissions. Advancements in reusable rocket tech and other propulsion technologies are making space travel even more environmentally friendly as we begin to travel to space again. If space travel continues to grow in the future, we will be forced to adapt even more, because even though they make up a small portion of emissions today, rocket launches are some of the most polluting technologies we have. Throughout the history of space travel, there's been an underrepresentation of both gender and ethnic minorities when it comes to both engineering and astronauts. In both the fields of engineering and space travel, there's an overwhelming number of men when compared to women, and in terms of ethnic demographics, there's an overwhelming number of European, American, and Asian astronauts. Recent missions to the ISS and other space travel agencies have made much progress in incorporating more women and minorities into their missions. Along with this, they have also made leaps and bounds in creating more diverse engineering teams to help tackle these space problems. While it is much better than it used to be, there is still room to improve, and in creating a diverse and inclusive environment is something that is important as we head towards the stars. To conclude this video, we hope this helped to demonstrate the nature of how engineers interact with each other and with other professionals within the workplace, in our case, government officials. The construction and operation of the ISS was made possible by the work of engineers and their collaboration with governments across the world.